This video is about finding the domain and the range of a function. So the domain is the set of all values that the input can have, the x can have. So the first example is a relation that is given as order pairs, and we have 4 order pairs. So the domain will be all the x values that we're using in those 4 order pairs. So those are my x values. So the domain is the set of the numbers -2, 0, 1, and 5. So since I'm listing 4 points, we'll be using this notation to say that it's the set of all those 4 points. Next, I have a graph. So we know a graph shows us the relation by showing the order pairs. So the first point that is on the relation is this point here, -4 and -3. We have another point here. Let's say this point also has an x and the y coordinate, this point, right? Each point on the graph belongs to the relation. So now we're looking at all the x values that are the x coordinates of each of these points that are on the line. So the first x coordinate that we use is for this point is -4, including -4. So we have this point. Now the point next to this point uses this x. The next point uses this x, and so forth. We can see that we're using all the x numbers on the x-axis that start at -4 and end here. This point here is the last point that is in the relation. So this point has a 3 and a 5 as the coordinates. So the last x that we're using is 3, including. So see that the point is a closed dot, so it means that I'm including the 3. So the x values that I'm using are between -4 and 3. And we can write this as an interval notation, -4 up to 3. We're saying the boundaries of my highlighted zone. Or we can use a set builder notation when we put this type of bracket and we say x such that, and then we say we put an inequality that's true for x. So x is greater or equal to -4 and less than or equal to 3. Next, we have this graph. This graph, it's formed by 3 portions. The first portion is this portion here. On this side, it has a closed dot, and on this side, it has the arrow. Sometimes we put the arrow, sometimes we don't, but if it doesn't have a dot, it means that we're continuing going down and down and to the left. It's slanted, right? So it will continue going down and to the left. So if we're looking at the x values on this side, the x value that we're using, let's say it's about -4, including -4 because it's a closed dot. And then to the left of that point, we're using all the x's on the x-axis that are to the left of -4. And as we move to the left, as we move on this portion of the graph, we can notice that my x-axis is covered all the way to the left. So we're starting from -infinity to -4. Everything left to the left of -4 is in the domain of this relation. Next is this portion of the graph here. So we have a closed dot on the left, and I want to have here an open dot on the right. I forgot to put the open dot. And my points start using the x on the x-axis at -2. It's the first point here and continue using the x's on the x-axis up to this point. This point has the coordinates 2, 2. But since it's an open dot, it means that I'm not including the 2. So the 2 will have an open dot or an open parenthesis here. So I'm taking all the values between -2 and 2, excluding number 2. And the next portion of the graph starts here, and it goes to the right. The arrow shows me that I'm continuing going to the right and a little bit up, slowly up. So that means the first point, this first point has the coordinates 3, 5. So the first x value that I'm using to graph this portion of the graph starts at 3, including 3. And then I'm continuing to the right of 3. Each point on the graph will use some x value on the right of 3. And I'm continuing moving to the right, to the right, to the right. So that means I'm going to positive infinity. I'm covering the whole right side of my x-axis. So the domain, and in this case I will only list the interval notation. The interval here, the green area, it starts at negative infinity and finishes at -4, closed. Then we have the red area between -2, closed, and 2, open. And then the blue area starts at 3, closed, and goes up to infinity, open. Since I can be in any of the 3 intervals, we use this notation. This is called union, which says x can be in first interval or in the second interval or in the third interval. Range is the set of all the values that the y can take, or the output takes. So if we're looking at this example, the range will be all the y values that the order pair uses. So the y values are 3, -3, -1, and 2. So we'll be listing all those values. So we use this type of bracket when we list the points, and we'll start by writing them in increasing order. We usually like to put them in increasing order here. So -3, -1, then it's 2 and 3. This is the range. Now in the graph, we're looking at the y values. So this point here has -4 and -3. So the y value that we're using to graph this point is -3, including -3. So we're starting with -3. The point next to this point uses this y value. The next point uses this y value. The next point uses this y value, and so forth. And this is continuous, right? So imagine that you're looking at each and every single point close and closer together. And we're looking at the y values of each of those points. And what is the area of the y-axis that we're highlighting? Well, the last point, it's this point, it's 3 and 5. So the last point is number 5 used. And this is the y area that we're using on the y-axis. Right. So if I'm, for example, if I'm looking at y equals 6, do I use y equals 6 to graph any point on my black line? No. Do I use -5? Do I use -5 to graph a point on the black line? No. So -5 and 6, for example, are not in the range. The range for us are y values that are between -3 and 5. So if I'm using the interval notation, the lowest value that we're using is -3, the highest value that we're using is 5, and we put the close brackets because we include those endpoints. And for the set builder notation, we will be saying y such that y is between -3 including -3 and 5 including -5. And the last problem is this graph. On this portion of the graph, we're looking for what y values we're using. This point here has the y value -2, so it's -4 and -2, including -2, and then we're looking at all the y values that points on this portion of the graph uses, and we can see that we're using the y values below -2. And my graph continues going down and down, so we're using everything from -2 to -infinity. Now on this portion of the graph, the second portion of the graph, my first point starts at -2 and 2. This is a horizontal line, so next point has a y coordinate of 2 also. The next point has a y coordinate of 2. Any point on this section has the y coordinate of 2. So here I only have one y value that I'm using, the y equal 2. And then on the third portion of the graph, I'm starting at 3, 5. So the y value that I'm using, it's 5, including 5. And if I'm looking at the trend of my graph, the y values increases, and increases, right? So I'm covering the y that are greater than 5 or equal to 5 and go to positive infinity. So the range starts from -infinity to -2, including. Then I have only one point, point 2, and then I have another portion of the graph that starts at 5, including 5, and goes all the way up to positive infinity. And since I have 3 intervals, I will be putting union in between. So remember, this type of bracket is used when you list